Welcome to the last session of the day, and the session will be question answering, the first question answering session, and we will have 5 talks. So the first 2 talks will be remote presentation, and the first one will be cross-lingual machine reading comprehension presented by Mr.
Good afternoon, everyone.
So let's start.
My name is EMNLP-IJCNLP2019 from Joint Laboratory of HIT and IFLATEC Research. Today I'm happy to introduce our latest work called Cross-Lingual Machine Reading Comprehension, which was co-authored by Wanxiangche, Ting Liu, Bingqin, Shijin Wang, and Guoping Hu. As we know that to comprehend human languages is very important in AI era, machine reading comprehension has become a trending topic in recent NLP research. So what is machine reading comprehension? It is a task to read and comprehend a given article and answer the questions based on the passage. So we could classify the machine reading comprehension in the following types. From the beginning, we will start with the closed style reading comprehension datasets, such as the CNN and Daily Mail, and we will progress to the famous squad datasets, which is a span extraction form. And in the recent MRC research, here are some conversational machine reading comprehension datasets, such as the COCA and the Quark. So what is the problem in the current MRC research? The picture below shows the datasets in English and Chinese. As we can see that the datasets are mostly in English and there are only a few datasets in Chinese. For other languages, the datasets will be even less. So the MRC research on languages other than English are not well adjusted due to the lack of data. So how to enrich the training data in low-resource languages? The first solution is to annotate datasets by human experts. It is in high quality, but on the contrary, it is very time-consuming and expensive. Another approach is to utilize the cross-lingual approaches, such as use multilingual representations, translation-based approaches. So in this paper, we propose a task called cross-lingual machine reading comprehension to address the MRC problems in low-resource language. And we propose several back translation-based approaches for the cross-lingual MRC and yield state-of-the-art performance on Chinese, Japanese, and French data. And we also propose a novel model called the dual BERT to simultaneously model passage and question in both source and target languages. The proposed model shows promising results on 2 public Chinese MRC datasets and set new state-of-the-art performances, indicating the potentials in CRMRC research. Before we introduce our approaches, we would like to mention the related work on low-resource MRC. Asai et al. 2018 proposed to use runtime machine translation system for multilingual MRC. They first translate context and question into a pivot languages and do reading comprehension in the pivot language, then generate an answer. Finally, they use an attention-based answer alignment system to project answer into original language. Here, we would like to list some of the concurrent works that closely related to our work, indicating that cross-lingual research become more important than ever. Also, it should be noted that the cross-lingual approaches are very important in recent natural language processing research. As most of the pre-trained models are in English, we will have to find a way to better transfer the knowledge into other languages. So we are going to introduce the approaches for cross-lingual machine reading comprehension task. Before that, we will give some preliminaries for better understanding our paper. In this paper, we mainly deal with the span extraction machine reading comprehension. The representative data is squad proposed by the Stanford University. The passage of the squad is from the Wikipedia pages and they segmented into several small paragraphs. The question was annotated by the human experts, including various types of questions. The answer must be continuous segments or say text spans in the passage. We also would like to give 2 important terminologies, source language and target language. The source language is for extracting knowledge which has large-scale training data, for example, the English. The target language is the language that we wish to optimize on, which has limited training data, for example, Chinese, Japanese, French, etc. So in this paper, we aim to improve Chinese MRC using English resources. So our source language is English and target language is Chinese. We would like to give several introductions to the back translation-based approaches. In this paper, we utilize Google Neural Machine Translation System to translate English to Chinese. As we can see from the table that the Google Neural Machine Translation System achieves state-of-the-art performances. So how to utilize GNMT system for cross-lingual MRC? The first step is to translate target sample into source languages. The second step is to answer the question using the reading comprehension system in the source language. And then we back translate answer into the target language. But for the span extraction reading comprehension task, a major drawback of this approach is that the translated answer may not be the exact span in the target passage. To solve this problem, we propose 3 simple approaches to improve quality of the translated answer in the target language. The first one is called simple match, which is to select an arbitrary span from the original passage, which is the most similar to the translated answer. If we have a few annotated data, we could further improve the answer span by utilizing the machine learning approaches. The first one is called answer aligner, which is to feed the translated target span and original passage into a target BERT and generate an extracted target span. Also, we could feed translated target span, original passage, and original question into target BERT to form an answer verifier and generate an improved answer span. So we are going to introduce dual BERT system. Here is the overview of dual BERT architecture. The dual BERT could be summarized with 4 steps. The first step is to create bilingual inputs by target to source GNMT system. The second step is generate source representations by the source BERT. The third step is, in a similar way, we generate target representations by the target BERT. Finally, we fuse the representations and output the final predictions. Now we are going to introduce our dual BERT in detail. The first component is dual encoder. That means we translate target input into source input using target to source GNMT system, which was introduced before. After getting source and target input, we could use BERT for generating representations. In this paper, we use shared multilingual BERT for this purpose. After getting target and source BERT representations, it is very natural to utilize multi-head attention mechanism to fuse them together. In the multi-head attention mechanism, there is a dot calculations. In this paper, we propose self-adaptive attention. Firstly, we calculate self-attention within BT or BS. This is designed to use self-attention to filter the irrelevant part within each representations. And then the dot attention will pay more attention to the self-attended part, making the attention more precise and accurate. After getting the fused representations, we use another fully connected layer with residual layer normalizations and generate the final output for the start and end position in the target languages. Our training objective is formed by 2 parts. The first is the traditional loss for target prediction, which is very simple cross-entropy loss. The second is loss for the source predictions, which are multiplied by a lambda. So here is a question: how to decide lambda? Instead of setting lambda with a heuristic value, In this paper, we propose dynamic approaches to automatically decide the lambda. The idea is to measure how the translated sample resembles the real target samples. We propose to calculate cosine similarity between the ground truth span representations in the source and target language. The ground truth span representation is formed by the start pointer representations and the pointer representations and the span representations. If the lambda close to 1, that means the translated samples are good, thus we'd like to use the auxiliary loss. Otherwise, that means the translated samples are very bad, thus we'd rather not use the auxiliary loss. In the experiment part, we will try to use squad and translated data to improve the performance of two Chinese reading comprehension datasets, CMRC 2018, which was also proposed by our team, and the DRCD datasets, which is in traditional Chinese. We strictly follow the original BERT implementation and use multilingual BERT as our machine reading comprehension model. Our implementation was on TensorFlow, and we use Cloud TPU version 2 for fine-tuning our system. First, we will take a look at zero-shot approaches. Zero-shot means we have no training data for target languages. As we can see from the first 3 lines, if we use better source BERT from the BERT base to BERT large, we can see that there is significant gains on the CMRC and DRCD datasets. Also, we could see that by utilizing the multilingual BERT, we could achieve the most better performance among all zero-shot approaches. Regarding the back translation-based approaches, as we can see that the simple match, aligner, and the verifier could give substantial improvements over the baseline system. Also, we could see that without squad weights, modeling input in bilingual space could substantially improve the performance. When we use squad initialized weights, as we can see that there is another significant improvements over the baseline system, and dual BERT again outperforms all previous methods. In this experiment, we demonstrate the effectiveness of simple match approach compared to using the attention alignment in the NMT system. As we can see that though our baseline system is higher than the previous work, by using our simple match approach, we could obtain similar or even larger gain. We carried out detailed ablations on the CMRC 2018 datasets. The first, we can see that pre-training with squad is very important for improving the performance. The second, with source BERT, that means we simultaneously modeling the input in source and the target language will have a positive effect on the final system. The other modifications, such as the self-adaptive attention, dynamic lambda, and auxiliary loss, seem to also have an important effect on the system, but not that salient. In the discussion section, we propose a question on the source resources, whether we should use larger data or the datasets in closer language. For example, if our target language is simplified Chinese, here are the 2 datasets. The first one is English that has 100,000 data, and the second one is in traditional Chinese, which has only 20,000 data. So to explore this question, we plot the performance using different amounts of pre-training data in English in black line and traditional Chinese in the blue line. As we can see that when the pre-training data is below 25,000, it is the exact size of the DRCD, the traditional Chinese datasets. As we can see that there is no much differences, and even using English pre-trained models are better than the Chinese ones. When the pre-trained data exceeds 25,000, as we can see that performance of downstream task continues to improve significantly. Based on the experiments, we came to several observations. If there is not much pre-trained data, there is no preference on the selection of the source language. But if there are large-scale training data available, we should use the one that has much bigger data rather than closer to the target language. Also, we could make use of data in various languages to exploit further improvements, and we leave this for future work. So let's come to the conclusion. In this paper, we propose a new task called cross-lingual machine reading comprehension task that aims to help low-resource reading comprehension system. At first, we propose several back translation approaches for basic cross-lingual MRC, and we propose a novel model called Dual BERT for modeling text in bilingual space and enriched representations. The experimental results show that our model could achieve state-of-the-art performance on Chinese, Japanese, and French MRC data. Regarding the future work, we would like to investigate utilizing various types of English reading comprehension data. Also, we would like to seek other cross-lingual machine reading comprehension approaches that does not rely on machine translation system. We would like to thank Google TensorFlow Research Cloud Program for supporting TPU devices and anonymous reviewers for their valuable comments on our work. This work was supported by the following funds from the National Nature Science Foundation of China. And here are the useful resources related to our paper, including the datasets, pre-trained models, and the Google Neural Machine Translation System. Thank you for your attention, and we hope you enjoyed our work. We have posted our source codes as well as other resources on GitHub. Don't forget to check that out. If you have any questions, you can either submit an issue on GitHub or send an email to my mailbox.
Okay, so any questions will be sent to the author's email, and I think they will give you correspondence.